Hello friends, in today's question, on applying a force F, point P is displaced vertically down by Y from equilibrium position. Find the force F in terms of constant K of the spring and displacement Y for the cases A and B. So these are two cases A and B. This is point P in the first case and it is pulled by the force F in the downward direction, and it is connected with the pulley with the spring S with the constant K, and the string is fixed at this some position. And whereas in the second case the pulley is connected with the string, one part is connected with the string and another part is connected with the spring whose constant is K, and this pulley is now pulled with the force F. Okay. So let us discuss for case A. For case A, we are going to draw the various forces which will be associated with figure A. So first of all, we have a spring and it is being pulled by force in the downward direction, so that there will be a spring force Fs acting in downward direction, and then there is a pulley which is connected with a string. So we draw, so this is a pulley, and now this pulley will be pulled in the upward direction by force Fs, and we are going to have tension T in downward direction. And if you want to draw the P in the equilibrium position, so we can say this is point P, it's being pulled by force F in the downward direction, and upward there will be a T tension acting on it. So these are the various forces for figure A. So under the equilibrium, we can say at point P, we are going to have force will be equal to tension. Okay, let this be question number 1. And in case of pulley, let this we call this a pulley A. For pulley A, we have T is equal to Fs. Okay. 2T will be equal to Fs. Let this be question number 2. And it is saying that when F is applied, the point P is displaced in the downward direction by Y. Okay. So on the application of force F, point P is shifted by Y in downward direction. Now as the string and the force is applied on the string, and the other part of the string, let us suppose this is 1 and this is 2. Okay, force is applied in the downward direction at string 2. But but string 1 is fixed, therefore we can say that therefore the spring is stretched by y by 2. And from here we can say that this implies that Fs will be equal to k multiplied by y by 2, and let us call this equation number 3. We are going to use equation number 1, 2 and 3 and find out the relationship between f, k and y. So now using equation 2 in 3, we put fs equal to 2t, so we get this as 2t is equal to k y by 2. Here we can say that t is equal to k y by 4. And now from equation 1, let us call this as 4. From equation 1, in equation 4, the t is equal to f, so we can directly write that f is equal to k y upon 4. So this is a relationship between force k and y for case number A. Now for case B, we can say that, let us once again draw the diagrams that are associated with it. We have a spring that is connected with the fixed point, and there will be force. Let us call this as Fs prime, and we have a pulley which is connected to one end with a string, and to another end it is connected to a spring. Okay, we can say that so we have a force F that is acting in downward direction, and we are going to have Fs prime as well as Fs prime on the both sides. Okay. Now we can also say that in case we are confused with this Fs, let us say that it has a tension T. Okay, later on we can prove that T is equal to Fs. We can say the tension in the string and spring will be same. This implies that our T is equal to Fs prime. And let us call this as B. And for pulley B, let us call this equation 1. For pulley B, F will be equal to twice Fs prime, and let us call the equation 2. Now what happens that with the force F, when the force F is applied, when force F is applied, pulley B moves in downward direction. Okay, pulley B will be moving in downward direction, but as the string is inextensible, the entire movement of pulley B will be dependent upon spring. But as string is not stretchable, entire movement of pulley B will be because of spring S. Okay, so let us call this S. Will be because of spring S, and the entire movement of pulley B will be because of spring S, which will be equal to 2y. Okay, which will be equal to 2y. Therefore Fs prime is equal to k multiplied by 2y, and let us call this as equation number 3. Now we already have Fs prime is equal to tension T, or we can put it directly using equation 2. Using equation 2 in equation 3, we get Fs prime is equal to F upon 2. So we get F upon 2 is equal to K into 2y, and from here we can directly write that F is equal to K into 4y. So this is a relationship between the force F, constant K, and the distance y for B part. Thank you.